In this video, we will be solving equations such as these by factoring. Now, keep in mind, in order to do this, I'm assuming that you have memorized the facts on this screen. If you have not, you need to pause the video right now and commit these facts to memory before going any further. One tool in your toolkit should be greatest common factor. So when I glance at this, I see that I have a tangent x here and a tangent x here. That is a common factor. So if I pull tangent x out and put it in the front, so now I'll have tangent x. That's going to leave behind the radical 2 and the cosine x, and then minus 1 to hold the place of the tangent x. And all that equals 0. So using the zero product property, I can basically split this problem right here. And I can get solutions by setting each of these factors equal to 0. So if I set tangent x equal to 0, I can get one or more solutions. And meanwhile, if I set radical 2 cosine x minus 1 equal to 0, I can get a solution or two from this. Let's start with tangent x equals 0. Where is that going to happen? For what angle will that be true? Well, let's look at our quadrantal angles. And remember, right here, this is the point 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Remembering that tangent is y over x. I'm going to go around the circle and write the tangent next to each one of these. If I do y over x, it's 0 over 1, that's going to give me 0. So the tangent here is 0. If I do 1 over 0, that's going to be undefined. If I do 0 over negative 1, that's going to be 0. If I do negative 1 over 0, that is undefined. So these are the two angles where the tangent is 0. And that's angle 0 and pi. So that's two solutions so far, x equals 0 and pi. Okay, now let's see what solutions I can get from the right-hand side. Adding 1 to both sides, I will have radical 2 cosine x is equal to 1. Dividing both sides by radical 2, I will have cosine x is equal to 1 over radical 2. Well, the cosine of what angle is equal to 1 over radical 2? We are talking about a reference angle of pi over 4. So I'm just going to say the reference angle is pi over 4. Now looking at a quick diagram of that particular reference angle, alright, these are pi over 4s. And these are the four angles that have a reference angle of pi over 4. The cosine of any of these will give me 1 over radical 2. Except for two of them will be positive, here and here, and two of them will be negative. Because cosine is an x value, and x values are negative to the left, positive to the right. In this particular case, I want positive 1 over radical 2. So these two angles will be solutions. So my two additional solutions then are x equals pi over 4. But this one is 7 pi over 4. So altogether we have 4 solutions to problem number 1. Alright, take a look at number 2. Let's go ahead and get 0 on one side. Be careful, whatever you do, do not try to divide both sides by sine x like this. It'd be very tempting to divide both sides by sine x. But you can't divide by a trig function because very often these trig functions have a value of 0, and then you're dividing by 0 and you've broken the universe. Instead, let's subtract sine x from both sides. So that's going to give me sine x tangent squared x minus sine x is equal to 0. Now see the sine x that is in both terms? That is a common factor. So once again, I'm going to use the tool of factoring out the common factor of sine x. And that's going to leave behind tangent squared x minus 1. And again, I can split the problem right here and do my zero product property and set each of these equal to 0. So here I will have sine x equals 0. And here, if I do tangent squared x minus 1 equals 0, then I get tangent squared x is equal to 1. Taking the square root of both sides, I will have tangent x is equal to plus or minus 1. Don't forget, when you take the square root of both sides, the solution can be positive or negative. Alright, we'll get more solutions that way. Now let's talk about the actual answers. So, sine of what angle is 0? Think about the quadrantal angles here. Okay, and remember how this is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Well, sine is the y value. So where is the y value equal to 0? Here and here. So those are the two angles where the sine is 0. And that is angle 0 and angle pi. So I have those two solutions so far. Now let's talk about tangent. Where is tangent equal to positive or negative 1? Now hopefully you remember that tangent of pi over 4 is equal to 1. So that tells us that the reference angle is pi over 4. Now let's draw that, and I'll recycle this diagram. Okay, these are the four angles that have a reference angle of pi over 4. Now, any of these, the tangent of any of these angles will give me some kind of a 1. But I will have a positive 1 here and here, and I will have a negative 1 here and here. However, I don't care, because I want the tangent can be positive 1 or negative 1. So I want all four of these answers. So I'm going to add the following four answers to my list of solutions. The first one is simply pi over 4. But this one is 3 pi over 4. This one is 5 pi over 4. And this one is 7 pi over 4. Okay, so we have a total of 6 solutions to this equation. Problem number 3. This looks like a factoring problem. Let's go ahead and try to factor this and see what happens. Okay, 4 cosine squared x. That might factor as 2 cosine x times 2 cosine x. That would certainly make 4 cosine squared. Now I'm going to ignore the middle for a moment. I'm going to come over here to the end. 1 can only be 1 times 1, so that's easy. Now, to see if this is going to work, remember that inner plus outer must equal the middle. Now, inner, I have 2 cosine x. Okay, if I multiply these. outer, I have 2 cosine x. I'm trying to get a middle of negative 4 cosine x. That will happen if both of these are negative. So that will happen if both of these are negative. Will that give me a positive 1 though? Yes, it will, because a negative times a negative is a positive. So great, we just factored it correctly. Now that we have it factored, we can use the zero product property. We can get solutions by setting each of these equal to 0. Now these are identical, so I'm only going to do one of them, of course. So if I set this equal to 0, adding 1 to both sides, I have 2 cosine x is equal to 1. Dividing by 2, I have cosine x is equal to 1/2. Now it's time to ask myself what the angle is. Cosine of what is 1/2? Well, start me off with the reference angle. Let's see. The cosine of pi over 3 is equal to 1/2. Alright, that's just one of those facts that we have memorized. Cosine of pi over 3. So that's the reference angle. Now look at this diagram to help focus your mind. Okay, these are the 4 angles that have a reference angle of pi over 3. Cosine is going to be positive 1/2 here and here, and it will be negative 1/2 here and here. Cosine is an x value, so it's negative on the left, positive on the right. In this case, we want positive 1/2, so we're going to pick these 2 angles for our solutions. So the first angle is simply pi over 3, but the second angle is 5 pi over 3. So these are the 2 solutions for problem number 3. In that last problem I mentioned that the cosine of pi over 3 was 1/2, and I just wanted to remind you that I'm assuming that you have memorized all of the facts on this screen. If you have not memorized these facts, you need to pause the video and take the time to memorize these before you go on. So I was referring to this fact right here. Cosine of pi over 3 is 1/2. But I will be referring to these throughout the video, and you need to have them memorized. Alright, let's move on to problem number 4. Again, this looks like a problem that we can solve by taking out a common factor. I see sine in both terms. So if I take out sine x outside of parentheses, then that will leave behind sine x minus 2. Okay, now using my zero product property, I can set each of these equal to 0 and solve separately. Okay, now looking at the left side, sine of what angle is 0? Well, if I picture my quadrantal angles, and this is 1 comma 0 and 0 comma 1 and negative 1 comma 0 and 0 comma negative 1, sine is the y value. So where's the y value? 0, here and here. So that's why I will have the following 2 solutions. X is equal to 0 or pi. Now, what about this equation on the right? Adding 2 to both sides, I will have sine x is equal to 2. So at what angle is the sine of what angle is equal to 2? Well, this bit has no solution. Okay, I'm basically crossing this out. Because look, the sine is the y value on the unit circle. Alright, this unit circle has a radius of 1. So the highest value that the sine function has is 1. And the lowest value is negative 1. you will never have a sign. There's no angle where the sign will be 2. That's not on the unit circle. So that just simply means that my only 2 solutions are the 2 that I got from the left hand side. Alright, this is extraneous. You can disregard it. Okay, let's move on. Alright, I keep waiting for a problem where we're going to have to use our double angle identities and such. I'm dying to use one of these. So far this has been a review of old material. It's good practice, but it's not new. So let's go ahead and we want to factor this. So if I get 0 on one side by subtracting 2. So then I will have 2 sine squared x plus 3 sine x minus 2 is equal to 0. I'm betting that this is factorable. My money is on factorable. 2 sine squared x could factor as 2 sine x times sine x. Now 2 can only factor as 1 times 2. Now it matters whether I put 1 and then 2 or whether I put 2 and then 1. I know not to do this. Alright, I won't waste time on it because if I put the 2 inside the first set of parentheses, that will cause a common factor here. And if there's no common factor in the original problem, there should be no common factor inside of the parentheses. So this will not be the way. So instead I will go straight to putting 1 here and 2 here. Now inner plus outer must equal middle. Inner I have 1 sine x. Outer I have 4 sine x. I am trying to get 3 sine x. That will happen if this was a negative 1 and if this is a positive 4. So that means this would have to be negative and this would have to be positive. Will that give me negative 2? Yes, negative 1 times positive 2 is negative 2. So this is the correct factorization. Now I can use my zero product property to get solutions. So we will set 2 sine x minus 1 equal to 0, and I will set sine x plus 2 equal to 0. Over here, adding 1 to both sides, I have 2 sine x equals 1. Dividing both sides by 2, I have sine x is equal to 1/2. Alright, at what angle, the sine of what angle is equal to 1/2? Well, remember those facts you're supposed to memorize. Sine of pi over 6 is 1/2. Memorize that. That tells me that the reference angle is pi over 6. Alright, that doesn't give me the answer. It just tells me the reference angle. Now consider the following diagram to help focus your mind. Alright, this is a diagram of pi over 6's. Okay, you're gonna forgive me for, alright, that's about the worst diagram I've ever drawn, but you know what? I'm just gonna keep going. So these are pi over 6's. 4 of them, these 4 angles are the ones that have a reference angle of pi over 6. Here, 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 and here. 2 of them will give me positive 1/2 and 2 of them will give me negative 1/2. We're talking about the sine function. These are y values on the unit circle. So it will be positive up here and negative down here. For this problem we want positive 1/2, so we want these 2 angles for our solutions. So that's going to give us x equals pi over 6, that's the first one, and 5 pi over 6 for this one. Okay, so I have 2 solutions so far. Now, what about the other equation? Subtracting 2 from both sides, I have sine x is equal to negative 2. Well, this is going to give us no solution. Alright, I'm not going to put a box around that or anything. If anything, I'm just going to put an x through it. Again, the sine function goes up and down like this. But remember when we used to graph these in the previous unit? The sine function has a high of positive 1 and it has a low of negative 1. It never goes higher than 1 and it never goes lower than negative 1. So there's no angle where the sine is going to be negative 2, which is way down here somewhere. It just doesn't get down there. So that's why these two solutions that we got from the left hand side will be our only solutions.